AP Calculus, it's really good to get to know how to use your graphing calculator. So if you were using graphing technology to solve this, what I would get you to do is type this into y1 and this into y2. So if we did that, go to our graphing calculator. Not on this app, but I'm sure there's a Casio app as well. So we go to y equals, clear the output we have. Square root of 3x plus 2.
Negative 6 plus x.
Negative 6 plus x. Now I'm going to hit graph and I think my window's probably off. Yeah, okay.
That's a tall window.
If your window is off, which sometimes it is, and if you told your graph to do something complicated, like sometimes sine graphs and cos graphs, your calculator takes its sweet time to draw it, and you're like, come on. You can always hit the on button to stop. It's like a break function. So you know in computer science you can sometimes break a program. Well, not break it, but like stop it mid-program. The on button does that. So now I can go zoom and 6, maybe the stand, oh, it's not quite enough. So I go to my window and I'm going to change my X max to 20. See if that's enough to show where they intersect. It is. So I can go second, calculate, number 5, intersect, enter, 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 and I get one answer at 12.217. To 3 decimal places, to the nearest tenth would be 12.2. Now that I read the question, always write 3 decimal places first for the exam, and then reread your question in case they decide to change it on you. But this question could also be non-calculator. So if this was a non-calculator question, you have to remember from grade 11 how you solve square root equations. Do you remember the steps or the process for solving this algebraically? Get the square root by itself. Good work. I love it when the first step is something that they did for you. You can feel really good about it. But yes, the first step is, can you get that square root all by itself on one side of the equation? Which it is already. Then step 2, square both sides. Hey, getting rid of a square root is easy if you square. But if I square that side, I have to square this side. And careful when you square the right side that you for sure FOIL. So you will get 36 minus 12x plus x squared. And this is a quadratic equation. So we make one side equal to 0. I'll choose this side so my x squared is positive. Move the 3x over, move the 2 over. And then we can factor, or the fact that the question said to the nearest tenth usually tells us that factoring is not possible. Okay? But this one is tempting. Oh, I love how this is like, this is a tempting quadratic. You see 34? 17 times 2, right? You know my times table. 17 and 2 makes 15 if you subtract. It's so tempting to think you can factor with 17 and 2, but it doesn't. Because it'll either have to subtract, and then you get a negative at the end. It just doesn't work. So we have to go to our quadratic formula. And what's interesting about our quadratic formula here plug everything in, simplify. You get 15 plus or minus the square root of 89 divided by 2. What's different from the answer that I have here than the answer I got on my graphing calculator? Besides that this is exact and that's a decimal. But I'll tell you that if you figure this out, you are going to get the 12.2 and you are also going to get another number. Negative what? No, doesn't work out perfectly to be negative something. It's another positive number. Yeah, figure it out for me. I'm curious. It's going to be like 3 point.
2.8.
2.8. So how come our non-calculator method got us 12.2 and 2.8? Our calculator method only got us the 12.2. Are we smarter than our calculator? Not this time. Sometimes we are, but not this time. This is actually an extraneous root. Because if you were to plug it back into the original equation, putting in 2.8 for x would keep this side as a negative 3.2. But square rooting anything is always positive. Sometimes you get extraneous roots because you plug the number back in and you end up having a square root of a negative number. Apparently bad. But in this case, you don't get a square root of a negative number. This side works, but this side is negative. And square rooting a number always comes out with a positive answer. So interesting that the algebra would give us that extraneous roots. One of the things you learned in grade 11, solving radical equations, when you square both sides, you always have to check. Because I could start with something that's not true, then square both sides, and get something that is true. No, I was attempting in my head. Oh, maybe. There we go. Yeah? There we go. 3.2 squared is 10.2. No problem. Okay. Question for practice on this one.